Hey everyone, for my algebra class, here's a video for week 4 functions. Working through this video and helping you understand what's going on this week. So functions are all about tables, graphs. We're going to do a little bit of function notation and just understand how to represent all these relationships between variables that we're working with. For week 4, make sure you're reading the sections in our online CK12 textbook. Take notes, use this video, use the video in the practice problems, use the textbook. Make sure you're understanding things and using them as a resource when you do all the assignments for this week. Again, come to my online classroom for clarification and help on anything. Message me. I'd love to help you work with stuff to not get stuck. Here's what we're going to be doing this week. We're going to talk about what is a function and determining if a math relation is a function or not. We're going to define these terms domain and range and talk about what they mean with a function. We're going to talk about domain and range using graphs, tables, and equations. We're going to write function rules that represent patterns in a table. And then if I graph a function based on a rule, pattern, or equation, we're going to use our Desmos calculator and talk about graphs. And ultimately write a function rule that represents a function in graph form. So a lot of graphing, a lot of patterns, a lot about writing these function rules and equations to represent just what's happening. So this week, we began learning something new in our class. So far, we've reviewed order of operations, reviewed working with fractions, decimals, and negatives. We've looked at evaluating algebraic expressions. We've reviewed variables, how to use the variables, and how to translate all these different situations and problems into symbols in math and expressions and equations. That was a hard thing we've been working on. And reviewed problem-solving strategies, making a table, thinking through how to translate problems into algebra. We've been working on all this stuff. When we talk about functions in mathematics, we're talking about all the stuff we've learned so far about equations, relationships, variables, and everything, but kind of looking at it with a new light, with some new symbols, a new kind of frame of mind mathematically. So we aren't going to be learning how to calculate or graph anything new. It's just looking at some new symbols and representations of what we already know. So here's our first definition. A function. When we use this word in math, a function is a relationship between two variables such that each input value x, so I'm starting with some number x, has one and only one output value y. What makes this different from than just any relationship is this whole idea of one and only one output value y. So if I have a value for x on my graph, on my table, in my equation, anything, it can only turn into one y value from my graph, table, or equation. And you may think, well, obviously, yeah, this has been happening, right? We've been doing this, but there's a lot of cases where this doesn't necessarily always happen. So we'll look at some of these. But each input value x turns into only one possible y value output for y. Now, if we're all about x and y values and thinking about input values and output values, then the domain and range are ways to describe those. The domain is all of the possible input values for x, so think your x values on a graph, on a table, all this stuff, all your input values that we can put into a function that actually work, that give us some value. Most functions we can use a lot of x values, but there are functions where we would get an error if we try and calculate it, or it doesn't work for certain x values. So the domain is describing, well, when does this function work? What are all the different values that I could put in for x, and what are all the ones that I can't? Range is the same thing, but only for y. So the range would be all the possible output values or y values that I get. So as I put values in for x, what kind of numbers am I getting back for y? Are they all positive numbers? Is it any number? Or is there a certain limit to what types of y values I get back? I want to be able to describe domain and range in terms of input and output values. All right, those are three huge words and concepts to think about, and we'll kind of go over these and think about these examples or these concepts with a couple of examples here for you guys. All right, here's our first scenario. An amusement park charges $10 for admission, but then $2 for each ride. So you get in, but then each ride costs another $2. Write a function that represents the total cost of admission and all the rides. So we're going to do this step by step and go really slowly through this, use our algebra, use our function notation, etc. So first step is, what are my variables? What is changing in this problem that I need to keep track of? All right, let me get my pen out. So I know that there's cost involved. That would be one of the variables, right? The cost changes, and the cost changes depending on the number of rides. How many rides? If I do a lot of rides, it's going to cost me a lot of money. If I only do a few rides, it's not going to cost as much. But that is what's changing in this problem. So I'm going to say, depending on how many rides I take, that's going to be my input value, right? The cost of my day at the amusement park is dependent on how many rides that I do. So there you go. We've just defined our x variables. X is how many rides I take. My output variable y is the total cost for the day. All right, the next step is, let's start making a table and doing some calculations and getting an idea of what's mathematically happening. So I'm going to make a table here. I got some input values and some output values. And I'm going to make, remember my input values was the number of rides. We just defined that variable. And my output is the cost. So we're going to play around with calculating different rides and the cost. So I'm going to do, what if I just do 0 ride, 1, 2, 3, 4, 5, 6, and 7. Okay, to figure out the cost now, switch colors. The cost is going to be $10 for admission, then $2 for each ride. So if I go in and do 0 rides, it's going to cost me $10, right? I'm still paying to get in, but I'm not paying for any rides. If I do 1 ride, it's $10 plus $2 for that 1 ride. So it'd be $12. And you can see quickly, as I increase each ride, it's just going to cost me $2 more. So let's do 14, 16, 18, $2 more for each increase of a ride. 20, 22, and 24. All right, we've got a table of values now that kind of represent what's happening in this problem. Some specific things that I could calculate based on this scenario. All right, third step. I've got my scenario. We made a table. Once I have a table, I can either draw a graph by hand, or I can use my Desmos calculator and plot the points on the table. So I'm going to go ahead and do that real quick and show you how to make a table of values on your Desmos calculator. Okay, here I am at our Desmos calculator, and let's go about putting in our table of values. So here on the left with the little plus sign, if I click on this, I'm going to add an item. I can add an expression. Note, we're going to add a table. As soon as I open in, there's got x and y values set up. And we specifically set for x to be the number of rides. In our table, we have 0 rides, 1 ride, 2, 3, 4, 5, 6. And we went up to 7 rides. Now we already calculated, we evaluated based on 0 rides would cost me $10, $12 for 1 ride, 14. We went up by 2 because it was $2 for each ride. And so there's our y values. Now we don't see anything right now because I've got to adjust my table. I could slide it over and start to see some things, but I can also change what I'm seeing on my graph settings. So I'm going to click on graph settings. For my x-axis, this is going to be number of rides, so I can actually define my variables in here. And we're going from 0 to 7, so I'm going to start at 0 all the way up. I'm going to go to 10 because I want to see a little bit beyond 7. We're going to go steps of 1. There, you can see now we're starting at 0 to 10 for number of rides along my x-axis. Now let's define our y values. So my y value is the cost of amusement park. And we're starting at 10, going all the way up to 24. So I'm just going to go from 0 to 40. Let's start with 40 and we'll go up steps by 5. And now we can see from $5, $10, there's my initial price of $10 for 0 rides. I can click on each dot. There's 1 ride is costing me $12. So I can click on the coordinates of each point and get a really quick idea visually of our table. It's a nice straight line, right? And then down below I can see the number of rides, and over here is the cost of the amusement park. So that's how you can put in a table of values and get a good graph to help you see, figure out, and work with a variety of functions. We put in a table of value for the functions, and we were able to plot the points for that function from our table of values. All right, let's go back to our PowerPoint. All right, so we have a table of values, we have a graph, and this is going to be a function because each input value, the number of rides, has only one possible output value for the total cost, right? If I pay my $10 to get in and I do 4 rides at $2 each ride, it's only going to cost $18. There's only one possible value that could be, right? Doing 4 rides can't cost $18 and $22. It's just, it won't happen that way. So when we have only one possible output value cost for each input value, that's an example of a function. Okay, so we have a function, we graphed it, we have a table of values. We know it's a function because every ride, whatever value I pick for rides, has only one specific cost associated with it. What is the domain and range of this function? Let's think about what those words mean. So the domain is all the possible x values, right? All the possible values, and we need to be careful with what the variable is. So remember, the domain is talking about the number of rides. Well, in this scenario, the domain, if I'm keeping track of number of rides, what kind of x values can I put in? Well, they can't be negative. In this particular instance, there's no such thing as doing a negative number of rides. We can't have fractions or decimals, right? How can you do 1.4 rides? So we can't have decimals. So the domain for this particular situation is all whole numbers. And whole numbers are positive numbers that are whole, including 0. Other times we'll be working with functions and the domain might be all numbers because it could be negative or decimals. Sometimes we'll work with functions and the domain is all numbers as long as they're greater than 8. So we'll look at it as we go through this whole class, this whole year, we'll keep revisiting domain and talking about, well, what is the domain of this scenario? What is the domain of this graph? But the domain is all possible input values that make sense for my function. In this case of the amusement park and keeping track of the number of rides, it's all whole numbers. And you might even say, what's a reasonable list? Maybe you can only do 50 rides in a day, right? So we can't have like 8,900 rides. Nobody could do that. So that doesn't make sense. But we'll just keep it as all whole numbers. All right, now let's think about the range. What kind of y values am I getting back? So remember, the range was the cost. So I need to think about, well, what values am I going to get for cost? Well, the first value on our table was $10, right? And after there, it went up by increments of 2, so $12, $14, $16, $18. The range in this scenario, because I can only put certain whole number in for rides, the range I'm going to say is all even, because $2 for every ride, they're only going to be even. So all even whole numbers greater than or equal to 10, because if I don't do any rides, I'm still paying $10. So that's the lowest possible y value for my cost, and it's all the even whole numbers above it. So 10, 12, 14, 16, 18, 20. I'm never going to have a cost of $19, right? Because every ride is $2 more. So there we go. So that's how I would express the range in this case. All even whole numbers, not odd ones, but all even whole numbers greater than or equal to 10. There's a little bit about how we think about domain and range for functions. Okay, so we've got domain and range. We have a function. We've graphed it. We've got a table. We've got a situation. The last step now is let's actually put together a function rule or an equation in function notation. So it may be easy to say, well, let's say the cost was equal to $10 plus $2 for every ride. That's one way of writing it as an equation, but we're going to do it in function notation, which is a little bit different. It's similar, but it's a little bit different in terms of how we write it up. So in function notation, we use our function f, and we can use f, we can use c, we can use anything. In fact, let me use c. Let's make this function c. So I'm going to do f. We're going to do our function c for the cost of the ride is dependent on how many rides, and there's the function notation part. Instead of just putting c equals, we have c with a little r in parentheses. And the r just means, well, what are we inputting? We're inputting rides into my cost function c. This looks like c times r, but it's really my function c inputting rides in for c. It's just the name and it's telling me what's happened. It's not multiplication. Here's where all the math happens. It says if you have a cost function based on the number of rides, here's how you calculate it. It's equal to $10 to get in plus $2 per ride. This is the same as this, but this is in function notation over here. And we'll be doing more about function notation throughout this year, getting used to this. This is your first initial view of it. And what function notation lets me do is say, okay, I can write, well, what is the cost if I do 3 rides? C with a little 3 in there, that's what it's telling me. What is the cost, C, in this function if I do 3 rides? I put 3 in for R. And so we'd say, well, you do 10 plus 2 times, put 3 in for R, just like my function says, and that would equal $16. So the cost, if I put $3 in, or sorry, if I do 3 rides, it's going to cost $16. That's how we actually use function notation once we set it up. All right, whew, so there it is. So we've got our function. Here I did f of x instead of c of r. There's my table of values that show what's happening in my function. We did that. There's the points that I first plotted in the table, but notice there's now a red line because I put this function in that we came up with. But I wouldn't necessarily use the red line because our domain and range are specifically whole numbers, positive whole numbers for the domain, and integers 10 and above, even whole numbers for the range. All right, hopefully that was a helpful introduction to thinking about functions, thinking about function notation, and how to start working with some of the problems we've been looking at. Okay, so quick review. A function is a special relationship between 2 variables. We can represent functions using a table, a graph, or equation. We did that. Function notation simply uses this f of x in place of using y when we write an equation. A function f takes an input value x and turns it into an output value y. So we've got this idea of inputs and outputs for x and y variables. The domain is all the possible input values that we can put into a function, and the range is all the possible output values that we get back. That's a lot of what we just covered. It's a lot of big ideas. If you're still feeling a little bit fuzzy, definitely look over some of the videos in the paper pencil problems, explain some of these more. You have some other examples in your reading textbook. We'll go over some of this stuff as well too. Make sure you're getting a solid start with function notation, domain, and range. Let's do some more examples here. What is a function rule for the following pattern in this table? What do we see happening here? So function rule, I can describe it using words, and then we'll also describe it using an equation and function notation. But if I'm looking for a pattern, we have 0, 1, 4, 9, and 16. That's interesting. We have 0, 1, 2, 3, and 4. And we want to look for, is there a relationship between x and y? Do we see some sort of pattern going on? Well, in this case, the function rule is we take x and I square it. So we're using a little exponents here. What I mean is 0 squared is 0, 1 squared is 1, 2 squared is 2 times 2, which is 4, 3 squared is 9, 4 squared is 16. If I wanted to write it as a function, I would say in this function, I'm inputting values in for x, and what do I do to x? Well, I take x and I square it. So this would be a function rule in words, and this would be writing a function rule in actual function notation. You're going to do some of that this week where you get a pattern, you look at a table of values, and you try and get a sense of what's happening in this relationship here. Let's graph this function rule. There's a few ways to graph it. One way is to simply make a table. Say, okay, for different x values, what am I going to get back for my function? So if I put 0, 1, 2, let's do a quick example here. So if I put 0 in, 3 times 0 squared is just going to be 0. If I put 1 in, I get 3 times 1 squared. 1 squared is 1 times 3, that's just going to equal 3. If I put 2 in, I get 3 times 2 squared. 2 squared is 4, 3 times 4 is 12. And I could quickly make some points, right? We got the point 0, 0. We've got the point 1 and 3. And we've got the point 2 and 12. So that's 3 points I could plot on the graph, and I could go back to find what's -1. I could keep going for 3 and 4 for x values. I could calculate as many y values as I think I need in order to get a sense of what this function is. And then when I have my graph, I could go through and plot them up, right? So 1, 3, 2, 12. There's just those 3 points right there. But we also have our Desmos calculator. So we could actually take this function and graph in our Desmos calculator very quickly to get a good idea of what's happening. So let's go back to our Desmos calculator and graph f of x equals 3x squared. All right, here I am at my blank graph. What's nice about Desmos is I can put it in as a function notation as well. So here's my function f. I'm inputting x values into my function. And what is it going to do? It's 3 times x squared. All right, there we go. And look at this one. It crosses the point 0, 0. And I can click on my mouse and get a bunch of other points. When x is, let's see, when x is 1, it looks like I get a y value of 3, right? We calculated that one. And the other one was 212. Yep, there's 212 right there. So this is a graph showing all the possible points that I could put in. Let's talk really quick about domain and range on this graph, on this function now, because we got those ideas here. So the domain, if you remember, is all the possible x values. So what can I put in for x? Well, looking on my graph, x can be a positive number. There's 0.91. There's 1.247. Those are x values that give me points. And if I zoom out, there's x is 4.09. That's in the domain. And x keeps getting as wide as I want. There's x 5.59. Notice this graph does not stop. In fact, if I wanted to think about it in terms of an equation, could I put 100 in for x? Does 3 times 100 squared calculate into something? It does. So 100 is in the domain. And also I see negative numbers. So I can have negative 1.8. I could put in negative 50 in, square it, times 3 and get a value. So what I'm going to say is if I'm describing all the possible x values, the domain of this function, it's all real numbers. I can put anything that's positive, anything that's negative, any fraction or decimal. I can put it in for x and calculate it out and get an answer back for y. So the domain is all real numbers. But now what's interesting is look at the range. What kind of y values? So the y values, if I'm starting here, I get a y value of 11.88. There's a y value of 5.62. There's a y value of 0.27. I get down to 0, but then my y values start to increase again. It's going back up along the y values. I can get as high as I want. If I keep zooming out, there's y values of 150. I'm going to keep going down. There's a y value of 499. But there does seem to be a limit with I never get below 0. My graph just stays in the positive y values. So if I want to describe the range on this particular function, the range is all the y values that are going to be greater than or equal to 0. I'm never going to have any y values in this function less than 0. So there you go. There's a good example of domain and range for a particular function, different from the last one. Let's go back to our PowerPoint now. So summarizing what we had in this one, we graphed the function, and then based on our graph, we were able to see the domain. What kind of x values are we playing around with? The domain is x is all, the domain x is all real numbers. And real numbers is anything on the real number line. Positive, negative, fraction, decimal, etc. The range we saw, range, remember, is talking about all the y values. The range was y values have to be greater than or equal to 0. I can never have a y value in this function that's less than 0. All right. So we did that, we graphed it, we shared it, we're good on graphs. Now let's talk about a function rule based on this graph. Here's a whole new example. Here's a new function. Let's see if we can find a relationship or a pattern going on here. So again, looking at my table, it's increasing. Looking at the graph in the table, it's increasing. It looks like it's increasing by 3. That's the pattern along my y values. So we always look for patterns. We look for some sort of sequence or something that I can say, well, it happens over and over again. This adds 3 along the y values. But then I want to compare that to, it's a relationship between x and y. So what's happening for my x to y values? If x is 0, y is 0. If x is 1, y is 3. 2 to 6, 3 to 9. Do you start seeing a pattern here? It looks like, since we're increasing by 3, every time x increases by 1, and from x to y, it looks like it's just a multiplying by 3. 4 times 3 is 12, 5 times 3 is 15. So in general, I take whatever x value, multiply it by 3, and that gives me the y value. I can see that here as well too, right? There's an increase in 3. There's another increase in 3. Every time I increase by 1 for x, my y values increase by 3 again. So overall, a function rule would be take x and multiply by 3. In function notation, I would say this function, when I input x values, here's what I do to get the y value. I take x and I multiply it by 3, and then that gives me this pattern in the table, and that gives me this pattern in the graph. So there's my function rule in function notation. Okay, let's review what we did. We talked a lot about functions this week. We defined what a function is and determined if a math relation is a function or not. And where a function is each input value for x has only one output value for y. We talked a lot about domain and range, did a couple examples of domain and range. We did function rules. We looked at tables and patterns. We looked at patterns and graphs and said, well, what's going on here? How would I describe this relationship in a function rule? And we graphed functions based on the rule or pattern or equation. And then we wrote function rules based on what we saw in a graph or a table. So a lot of stuff with functions. Have fun this week working on this stuff. And look forward to working with you one-on-one to help you out.